In order to do these notes, you're going to need to have this file up, these notes files. Sorry, I did not copy them for you. I made a last-minute decision on Friday to kind of extend this to the weekend, so I didn't have these ready. But here's a Dropbox Word file. To remind you people about Word files, if you do not have Microsoft Word, your options are to open it up on an iPhone using Word, just to kind of see the problems. You have a second option of going to OneNote and pulling it up there. This is your OneNote page, and you can see this page will be here. You don't need to have Microsoft Word to do that. You can do that from the web. You can do that from the OneNote app on Macs, and you can do it from the OneNote app on phones and tablets. The third and final option is to take the file, download it from Dropbox, and upload it to YouTube or upload it to OneDrive, and to take a look at it. The fourth and final option is just to open it in Dropbox and pray that it looks like it does right now so you can see everything. So between one of those four you should be fine. Now the next thing you need is your calculator. You're going to need a graphing calculator. I would start a new file and have a new graph file on it, or open a new graph on it. So that should be ready to go. Let's get started. These are the word problems. We're just going to do these examples so you can start stuff later. Again, you're not going to have this sheet. If you do print it out, great. If not, we're just going to take some notes off to the side. So I'm going to open up a blank note page just how I'd want. Number one. Again, I have this right by my side. You guys should too. Flight of the Vomit Comet. Name of an airplane. These are an actual story about what they use. And it's modeled by the quadratic equation h of t equals -16 t minus 4 squared plus 36,000. That is 36,000. And what we want to know is what the units are. So t is in seconds, and h of t is in feet. And what we're going to want to do is actually model this in our calculator. So I'm going to use the pause frequently here to plug this in. Okay, so I just plugged that in. If I hit tab, I can actually I can actually see that I did, but I can't see anything, and that should be for obvious reasons. My height needs to be much higher. If I put in a test point, I need to have something way up there. In fact, my vertex is at 436,000. So why don't I try a height of 40,000 just to see what's going on? Okay, now I can start to see stuff. Maybe let's make this like -10. And then cycle through tab, -10. No, I've got -9. Let's make that -20. And, sorry, I keep typing the wrong negative. -20. And positive, okay, I need to get bigger, maybe 100. Okay, now we're getting a view that looks okay. Again, I've got something high enough as like 40,000 and something low, wide enough here so I can see the whole thing. I'm actually going to drag this into quadrant 1, and you guys should realize why this should be quadrant 1. We're talking about time and height, and both of those need to be positive. So I can even customize this just a little bit further, tighten that down to maybe 70, and move this. Okay, that's fine. This gives us a good view of the parabola and what we need. So my window, and it asks you to put a window in. I'm just going to put like maybe -17 to 73 for x, and for y I'm going to go from like, I'm just approximating -2, or well, let's see, this is like actually it. I can't see the y min. Let's take a look at what it is. Hit menu. We're going to go to window zoom and window settings, and now I can see all of them. So just guesstimate or just approximate. I mean, it's not that big of a deal. -2,000, 40,000 is plenty. Doesn't have to be exact. So come back here and let's look at the questions. So the questions are actually asking what is the maximum height and at what time does that occur. So I'm going to take notes here. We want max height and time. Well, max height and time that occurs is the max feature on the graph. So I'm going to go to the graph. I'm going to hit menu, analyze graph, and maximum. Like before, it's left bound, right bound, or lower bound, upper bound, and I get this. Now this isn't very useful, 3.6 times 10 to the fourth. If you know your scientific notation, that's okay. I'm going to go to settings in the dock menu, and change my document settings so that my display digits should be at a float. Let's change it to like a float 6. Hang on, let me pause this a second. Okay, well that's not obvious. You got to go to menu settings here, which is stupid. Menu settings while you're on the graph, and change the display digits to maybe like a float 5 or something. So that, and I keep grabbing that, I'm sorry. So that gives me 436,000. That should not be a shock. That 436,000 is the vertex. I know that at 436,000 is the vertex. So that actually answers the question, and I can write that out. At t equals 4 seconds, we have max height of 36,000 feet. Second part actually says, what is the height of the vomit comet at 20 seconds? So then I want at t equals 20, what is h? In other words, what is h of 20? So there are two ways to find that, and I'm going to show you both of them. One of them is to actually go to the graph, and let me pause while I remember this, just to make sure oh no, wait, I do. You're going to go menu, trace, graph trace, and you can see this little blippy thing. Now you can press left and right and slide this left and right as you want. There's no guarantee it's going to get to 20, but a quick way to do it is actually just to type in 20. You see it says x equals 20, and I press enter, and blippy thing goes all the way to 20, and I see 31,904. So h of 20 is equal to 30,904 feet. A second way, in a perfectly legitimate way, is to actually go back to the home screen, add a calculator to this, and in the calculator page we're going to hit the variable key, call up f1, which is the function that we have stored in f1, and just say f1 of 20, and it will give you that same thing. This is very useful if it's not on the graph itself. As a final move, just for the purpose of archiving these notes for you guys, what I'm going to do is go back here. We're just going to do a little quick insert, screen clipping, and grab this. Okay, so next one. Let's go to part number 2. I'm going to pause while I save this file. This file I'm going to work on is saved in the Dropbox folder of this. Sorry, I keep getting emails. You guys have access to this folder from my website through Dropbox. These two files are Inspire files that you can open up on your home computers if you have the Inspire program installed. If you don't, you can at least put the 30-day trial in and come beg for a product key from me from the math office. But that's a way to see these files kind of going on. So anyway, number 2 says an arrow is shot upward with an initial velocity of 50 feet per second. The height of the arrow, h of t, in terms of time, since the arrow was released, is h of t is equal to 50 t minus 16t squared. So let's graph that. I'm in here now. I'm going to go actually to this document menu, insert, and I'm going to insert a new problem. So I can see the, okay, now I want to graph. I can see I have 2.1 now, so this is problem 2. So these first 2 pages were for problem 1, and the second one's for problem 2, and I'm going to graph this. I'm going to pause it while I do that. Okay. It's the same thing. I have kind of a bad view of this. Let's tighten that. Let's maybe make this a 5. Maybe make that a -1. Maybe make this a -1, and make this height be something maybe large, like 400. Oh, that's too large. Let's bring that down to 100. Maybe not even that much, maybe even like 70. Ooh, I don't even need that high. Let's try 40. There we go. Actually, I'm going to be picky and make it 50. Okay, this is the process you just have to go through, and then I'm going to move this kind of up to get a better view of it. But there's a graph. It says, how long after the arrow is released does it reach its maximum height? Well, from a graphing calculator perspective, oh, hang on, let's put our window down. X is going to be, let's see, that's from like -1 to 5. Again, I just guesstimate, -1 to 5. And Y A good window would be from -4 to 50. And then let's go back. So question A wants basically the vertex. So we've got a couple of ways we can do the vertex. Calculator wise, we can go menu, analyze graph, max, left, right, and I get this. 1.5625 and 39.063. And let's just round. It says how long after the arrow is released does it reach its maximum height? So that's t is about 1.56. So we'll just go about 1.56 seconds. Max height is the y value, 39.06 feet. So I just rounded it to the nearest hundredth. Then it says at what time is it 28 feet off the ground? Well, I basically want to figure out when this point moves, and I can do a trace on this. When the point moves left and right, when is the y value 28? Well, there's actually going to be two places it's 28, and this little blippy thing is not going to click right in at 28. So I'm going to press escape, and we're going to try a different thing. I'm going to graph the line y equals 28. So if I press tab and then press 28, hang on, this thing freaks out on me sometimes, 28, and I get a horizontal line here. And I can move this out of the way. This is my text label. You can right click and hide that. So you can see these are the two places I'm looking for. Well, let's do an intersection. Analyze graph, intersection. Again, left, right. And then I'm going to do the same thing. Menu, analyze graph, intersection, and we're going to do it right here. And I'm going to move this label out of the way so I can read these two things. And this happens at two places, at 0.73 seconds and at 2.40 seconds. So I'm going to say at 0.73 seconds and 2.40 seconds. It is appropriate to put that last zero on the 2.40, so it's, you know, it's 2.40 and not 2.39 and not 2.41. It's called significant figures, and we'll learn about that later. Then it says at what time is it 10 feet above the ground. So I'm going to go back here. Let's move this up here. No. Let's move this way up here. Get this here. And I'm just going to hit tab and graph y equals 10. And we can see a line down here. Same thing. Menu, analyze graph, intersection. And let's see. Now it's actually asking for me to select something. It says graph question mark. Basically it wants to know what two graphs do I want to cross. So I'm going to hover over the blue line and click, and then I'm going to hover over this black line and then click, and then left, right. Because you can only cross two graphs at a time. So one of my answers is 0.21 seconds. So at 0.21 seconds. And then my other answer, menu, analyze graph, intersection. Click on the two graphs we want to cross, blue and black, and then left and right, and I get 2.91. So, and then 2.91 seconds. Number 3, potato farmer has 400 bushels of potatoes that she can now sell for $3.20 per bushel. So I've got 400 bushels at $3.20 per bushel. For every week she waits, the price per bushel will drop by 10 cents. So for every week waited, price per bushel decreases by 10 cents, but 20 more bushels. This is a very common type of problem where you have a choice to make. You know, how long does she wait? She can get more bushels, but the cost is going to drop. So when does she just cut, stale, and sell? A says let W equal number of weeks after, well, the present, after now. And it says write an expression for the price per bushel in cents after W weeks, and then an expression for something else. So the first thing is I want price per bushel equals, well, the price per bushel is right now $3.20, but every week I wait it decreases by 10 cents, so I'm going to subtract 0.10 W. I'm going to switch colors to something just a little bit brighter and a little bit thicker. Let's go there. Actually, let's go to that one, and that should be better. Just a little bit thicker too. Sorry. Okay, so that's the price per bushel. In fact, I'm going to call that P of W. P per price and 3.20 minus 0.10 W. Then it wants a let's see, it wants another expression for the number of bushels to be sold. So number of bushels sold in terms of W. Well, we start with 400 bushels and we add 20 more bushels for each week. So I'm going to give that another letter. If I had you guys in class, I'd ask you what letter you want, but we'll just call that B of W, bushel sold for W, and that's 400 plus 20W. So I've got two expressions here. Now we're going to move on to part B. I'm going to keep this red pen. The total revenue equals the price per bushel. So revenue, meaning how much you make, is equal to the price per bushel times the number of bushels. And it wants you to write in a quadratic function that will find the total revenue. Well, we already have the building blocks here. I'm going to call the revenue R of W, and that's going to be equal to the price, P of W, times the number of bushels, B of W. And then when I replace what I've made for each of those, my price is $3.20 minus 10 cents for each week, and the number of bushels is 400 plus 20 times the number of weeks we wait. I want you to take this equation and just compare that to the basic revenue. $3.20 times 400 bushels. That would be now, but we're waiting a number of weeks. And so that's where we get the 320 minus the 10 cents for the number of weeks. And that's where we get the 400 plus 20 times the number of weeks. And if I graph that, so I'm going to go ahead, I'm going to go to this document menu, insert, number 4, and problem, number 1, and then a graph. So I'm on problem 3. And then let's graph that. I'm going to pause it while I graph it. Okay, graphed it. I see nothing. Let's change my top to like maybe 100. Nope, we want to go higher. Now, my X should definitely be bigger because I'm trying to wait a certain number of weeks. So let's move this up to like 200. Let me pause for a second. Maybe if I look at what this would have been, I can get an idea. Round that down to 3. 3 times 4 is 1,200. So I should be up by 1,200. Let's go 1,500 and see if I see anything. 1,500 high. There we go. Okay, now I see something. That's at least a logical way to, instead of guessing. And then we want this to be on a downswing. So let's maybe make that 20 weeks. Oh, I probably typed something in wrong. Hard to do with the pen here. Okay. 20 weeks, no. Let's try 50 weeks. No, maybe 40 weeks. There we go. And then just slightly tilt this up so I can see the axis. And my window is going to be like -9 to 40 and -10 to 1450. So let's just kind of state that right here. My window is -9 to 40 and -10 to 1450. Lots of acceptable windows there, and I'm just estimating what mine was. But it says if she wants to maximize her revenue, how many weeks should we wait to sell her potatoes? So that's part C. What do you think she wants to know? Well, you probably clearly want to know what the top of that graph is, because the Y represents how much money you're making. See, on the way up, you're making money, and this like zero, this y-intercept represents at the start of time. So as you wait a few more weeks, you make more and more money, but if you wait too long, the price reduces too fast, even though you're getting more to sell. So if I go menu, analyze graph, max, left, right, I don't see that. Let's just move that down. Remember, you guys can click, hold, drag. I get 6 weeks, and 6 weeks and 1352. So the question just said, what is the time? So she should wait 6 weeks. to maximize revenue. Okay, new problem. Number 4. This is one of the most fascinating problems I've ever read. Seriously, read this problem because this is crazy. This guy jumped out of a plane, bailed out of a plane without a parachute at 21,000 feet and survived. That is 4 miles in the sky. How does that happen? It's a long story. But anyway, you got a function here describing it. So let's go ahead and graph that function in the calculators. I'm going to pause while you do that. We're back. I've already graphed it. Here's the equation. T is in seconds, h of t is in feet. There's my window. Here's what the graph looks like. And this is asking a few basic questions. So at t equals 5, and if you remember how to do this, we're going to plug 5 in, and we can do this very quickly. Menu, trace, graph trace, and I'm going to put 5, and then just press enter. And it says 521580. So 5 at t equals 5. He was 21580 feet above ground. Then for the next one, it says how many seconds did it take for him to fall 10,000 feet. So he fell 10,000 feet when h of t is, well, let's see. At t equals 0, he started at 21,980 feet. So let's think of it this way. Oops, my hand hit that. T equals 0, 21,980 feet. T equals what? We want 10,000 feet fallen. So that's 11,980 feet. So I'm going to graph y equals 11,980. Tab, y, f of x is y, so y equals 11,980. And that should visually represent, him falling. Think of that red line as being him falling. You see, we can just move it up and down if I want to. That's a little more advanced, but you can actually do that. Anyway, we're going to do an intersection, menu, analyze graph, intersection, left, right, and boom. Nope, I just changed that graph. Hard thing about clicking. Let's move that point there. 25 seconds later. So that's, let's see. I'll just write it as t equals 25 seconds, and we'll move on. And then this, I don't like leaving that hanging. That's what that was intended to be. C, how many seconds did it take him to fall 20,000 feet? So if he falls 20,000 feet, I want to know t equals what when h of t equals 1980 feet. So he's close to the ground, and then let's just graph that. So quick way to do it would actually be to take this, change this to 11980 because I don't need it anymore. So I'm going to press enter. Fell down. Your intersection point was deleted because we don't need that anymore. So then if I go menu, analyze graph, intersect, left, right, I get this label. Move that up, and that's at 35.355 seconds. So t equals 35.355 seconds. I know I usually round to the hundredth, but I'm just going to leave that there. And then how many seconds did he fall before he reached the ground? So that's t equals what when h of t equals 0. That is a 0, an x-intercept or a root. I'm actually going to click on the background and move this graph up just a little bit so I have a little more room there. Menu, analyze graph, 0. I want a 0. See, it actually asks me to click on the graph because I have 2 graphs up there now. I'm going to click on the blue graph and then left, right, and I get a 0, 37.064 seconds. Okay. Now number 5. Number 5 is just kind of back to a basic problem. A pen is to be built around a wall from 72 meters of fencing. And so here's a wall, and then here's a pen, and the problem labels this as X. And so I'm actually going to use a different color to draw this pen so you can kind of see, okay, so this is X, this is X. This right here is 72 minus 2x because the total fencing we're using is 72 meters. And if I write a quadratic equation that needs to be maximized, because I want to maximize the area, so I'm going to go area of x is equal to 72 minus 2x times x. And it says determine the value of x that maximizes the area that will be enclosed. Well, this one I'm going to try to do here without a calculator because I can do it really quickly. One of the things I can do is take this and factor a 2 out, giving me 36 minus x, and then an x here. This means that my zeros are 0 and 36. So if I do a sketch of this graph, I know that here this is a 0 and this is 36. So this thing right here should be at 18. Now, how does that help? Well, because for question B, I know that when x equals 18, I'm going to maximize this. So this happens at x equals 18. 18 meters. The question doesn't even ask the maximum area, but if I wanted to know what the area actually was, all I'd have to do is just be to plug that back in. So at 18 meters. Now, you can plug it in your calculator. Let me briefly pause this. And there you can see that the vertex of this graph is the same thing. So, moving on to the last one, number 6. Number 6 is just like a basic word problem question. It's saying the sum of two numbers is 30. So, if I take, let's see, sum is 30, and then I want the greatest product. So this should be a one variable question. We're going to say let x equal a number, and then if the sum is 30, 30 minus x equals the other number. And so I know that the product, p of x, is equal to x times 30 minus x. That's what a product of two things is. Now, once again, let's try to do this without a calculator because we can do it very quickly. I know the zeros are 0 and 30, which means that if I'm trying to graph this with zeros of 0 and 30, you may ask, how do I know it doesn't go like this? Well, think about if I multiply that out, I'm going to get 30x minus x squared. That's a negative x squared. That's a downward parabola. It has a negative a value. So the graph is definitely going like this. And halfway between the zeros should be 15. And so if the 15, if x is 15, my numbers are 15 and 15. This should actually make sense because the greatest product is going to occur when the two numbers are the same. And that product will be 225. We are done. There is a worksheet. It's going to be on blue paper, and I have it, but it's also attached to Monday's homework. If you want to do it or start it, you can. If you're bored during the Super Bowl or if Katy Perry sucks for some reason. But other than that, we're just going to work on it in class.